Hey guys, Mr. Yaisley here. So we're on to lesson number 17 in chapter 4, all about writing linear functions. And lesson number 17 is talking about specifically identifying correlation. And what you should have learned from your vocabulary is that correlation deals with one thing being in conjunction with another. When something happens to A, that causes B to happen, right? And so these things are constantly happening. So if we think back to the scatter plot from lesson number 16 with our smoothies, what we found was there was a correlation there that when our smoothies had more grams of sugar, they also had more calories in them. So there was a correlation between those two things. More grams of sugar meant more calories. And so just as a reminder, the definition of correlation says there's a relationship between the data sets. So again, more grams of sugar, there's one data set, more calories, there's the other, and there was a relationship between them. So when we're talking about correlation and we're looking at these scatter plots, we kind of have three potential types of correlation. We can have positive correlation, all right, which means that we've got data that as X increases, Y increases, so it looks kind of like that. It's trending upward, so as X increases, Y also increases. So that would have been like our smoothies that we saw there in lesson number 16. You can also have what's called negative correlation, and this says that as X increases, Y tends to decrease. So the more I get of X, the less I have of Y. And then the final one you might have would be no correlation. And that means that there's just not really a relationship between the two things, right? No matter what happens with X, Y just kind of does its own thing. Or whatever happens with Y, X kind of does its own thing. So again, no correlation. They're going to typically look like that on a graph. So what we can do through this information is we can kind of figure out trends. We can figure out relationships between two things, and we can identify this even just by looking at graphs. So that's what we're going to do in example A. So if you shift your paper up just a little bit, example A here says to tell whether the data shows a positive, negative, or no correlation. So when I look at this first graph, which deals with age and vehicles owned, they're saying, hey, X is person's age in years, so how old somebody is, and then number of vehicles owned would be the Y-axis here. So when I look at this data, I see initially the first point I have, followed by the second point, kind of looks like it's starting to trend upward. But then the third point drops way down here, right? And then the fourth point, it kind of moves up. Fifth point, almost directly up. Sixth point drops back down. Seventh point drops back down. Eighth point kind of moves up. So there's not really any specific trend. It's not creating a nice little trend upwards like this all the time. It's not really creating a trend downwards like this all the time. So there's no real correlation when I look at. So when I would answer that, is there a positive, negative, or no correlation? This looks mostly like the no correlation. So I would say no correlation. Because again, remember, this person right here who's about 21, 22 years old, they've owned 4 vehicles. This person right here, they're 31 and they've only owned 1 vehicle, right? This person right here, they're 30 and they've owned 5 vehicles. So there's just, it's kind of all over the map. And if you think about it, how many vehicles you owned is kind of, well, how well did you maintain the vehicle? Did you have any accidents? There's a lot of things that play into that. So no correlations really happening between those two pieces of information. Now, when we look at the second one here, which is talking about temperature and coat sales, the X value is talking about the average daily temperature. So we're starting at 0 degrees, 35 degrees, 40 degrees, 45. So it's getting warmer and warmer as we go. And then the number of coats sold per day, we're starting at 0 and climbing. Well, if we look at this, we can kind of see that there's kind of like a downward trend happening here. When it was 35 degrees, they were selling over 60 coats. When it was 40 degrees or close to 40 degrees, still pretty close to 60 coats. When it was right on 40 degrees, right around 50, it's pretty much trending downwards. Now, trending downwards does not mean that every point has to fall directly and perfectly in line. Because as we see here, this one kind of drops and then it moves back up a little bit. So there is a little bit of fluctuation, but if we look at it, it's pretty relatively, as x increases, y is decreasing. So when I look at that, that looks the most like negative correlation. And so I would say, hey, this has a negative correlation. As x is increasing, the temperature is getting warmer, right? The amount of coats being sold is going down. All right, now example B, if you move your paper up, we've got a little bit more going on with this one. All right, they've asked us to make a scatter plot from this table they've given us. So we're going to have to graph this data. Right? Then after we've done that, they want us to tell whether that data shows a positive, negative, or no correlation. So we've got to kind of put the two pieces of information from lesson 16 and 17 together, right? So in order to do this, in order to plot data on a table, we have to create ordered pairs. Well, this is talking about the age of cars, which represents our X value, and then the value in thousands of dollars, right? Y. So we're trying to see, is there a relationship between the two things? So how old the car is, does that represent, or does that have a correlation with the value in terms of thousands? Now, in order to plot anything on a graph, we have to recognize that, hey, these are ordered pairs, X and Y. So my ordered pair right here would be 1, 24. My ordered pair here would be 2, 21. My ordered pair here would be 3, 19. Ordered pair here, 4, 18. 5, 15. 6, 12. 7, 8. And 8, 7. Right? Now what you may have noticed is that all of your X values here are positive, as well as all of your Y values here are positive. So we're going to be working in one of those quadrant 1 graphs. So what I want to do here is I want to draw my graph, and I'm just going to put my lines here. All right? So I'm going to call this my Y-axis. All right? And I'm going to call this my X-axis. Now notice, all right, this is my Y and this is my X. I didn't connect them yet. And the reason I didn't connect them yet is we need to figure out, do we need to make one of kind of those little funky signs where we have a big jump from 0 to some other number? So when I look at this, I see that X is counting by ones and it literally starts at 1. So I don't need to make a big jump on the X, so I'm going to go all the way to that spot. Now on Y, we start at 24 here, but it's getting less and less and getting all the way towards 7. So I think that I can fit all of those numbers on this graph. So I'm not going to do any sort of jump. So I'm just going to make it a normal value. And so this would be a starting point. This would be 0. So now I need to label my graph, right? So first thing I need to do is put what I'm counting by. So on the X-axis, I am counting by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Now I also need to label, what does that actually stand for? Well, that talks about the age of a car in years. So I'm going to write that down below, and I apologize, I didn't quite give us enough space here. Age of car, and then period years. So we got to kind of squeeze it in there, but we can do it if we paid attention to what we're doing. All right? Then Y, what would I might want to count by here? Well, I see that here we're kind of going by 3s, all right? Then a 2, then a 1, then a 3, then a 3. So it's kind of varying. So what I'm going to choose to do, just to make sure, I see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 lines that I can use to graph this, and the biggest number I have is 24. So I know if I count by 2s, I should be able to get all of those numbers on there. So I'm going to count by 2 here, which I can do. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So, and I'm allowed to do that. As long as I label it, I know what I'm counting by. I can count by 1s on the X and 2s on the Y. That's completely fine. Last part is we need to label the Y-axis and what it's talking about. So it's talking about the value in terms of thousands. So even though we had numbers like 24 or 21, that really means 24,000 or 21,000. All right, so last thing I need to do is I need to plot those points. All right, so 1, 24. That tells me go right 1 and up to 24. So there is my first point right here. Second point, 221. That tells me to go right 2 and up to 21. Now I don't have 21 labeled, but I know that it's directly in the middle of 22 and 20. Third point, 319. That says go right 3 and then up to 19. Same situation, I don't have 19 labeled, but I know it's directly in the middle of 20 and 18. Third one, 4 and 18, so right 4 and up to 18. That one's labeled real easily. Fifth one, 5 and 15, so right 5 and up to 15. Same idea, don't have it labeled, so directly in the middle of 14 and 16. Sixth one, 6 and 12, so right 6 and up to 12. Seventh one, 7 and 8, so right 7 and up to 8. And eighth one, right 8 and up to 7. Again, not a number directly on the line, so I need to put it between 6 and 8. All right, so now I've plotted all the points of the data that they've given me. So now the last thing they've asked me to do is to tell whether this data shows a positive, negative, or no correlation. Well, as I'm looking at this, I'm saying as X is increasing, as the number of years of the car goes up, I'm noticing that the value is going down. Well, if we remember, that is a negative correlation. It is trending downwards as X is increasing. So that means that there is a negative correlation. So I would just say it is a negative correlation. All right. Well, if you have any additional questions about determining correlation or plotting a scatter plot or any of that, please let me know. Again, make sure you've labeled these very clearly, made it very obvious of what's going on. But again, if you have any additional questions, please let me know. Otherwise, continue on in the chapter.